Hey everyone, welcome back to our YouTube channel, your go-to space for everything cybersecurity. I am Sanyukta, and in every video I post tutorials, demos and deep dives into how systems are attacked and how you can defend them. Whether you are a student, IT professional or just curious about how hackers work, you are in the right place. Before we start, don't forget to like, share and subscribe for more insights on cybersecurity, compliance and risk management. Turn on notifications so you never miss any update and start learning today. Have you ever used a website where your comments or feedback magically appeared in bold red text or as a pop-up? It might not be magic, it could be HTML injection. It's a simple but serious vulnerability that many developers overlook and attackers love to exploit. Let's break it down. Before we dive into today's topic, HTML injection, let's take a moment to introduce who we are. Looking for a trusted cybersecurity partner that is recognized across the globe, whether you are in a finance, healthcare or e-commerce, your security needs expert hands. Let us introduce you to Vista Infosec. Vista Infosec is globally recognized vendor-neutral cybersecurity consulting firm founded in 2004 and headquartered in Mumbai, India. With over 2 decades of experience, we help organizations across the world from the UAE to US stay secure and compliant with global standards like PCI DSS, SOC 2, HIPAA, GDPR and more. We are not just experienced, we are certified and trusted. Our services include vulnerability assessment and penetration testing, attack surface management, information security audits, GRC consulting, security awareness training. Industries we serve like banking and financial services, insurance, healthcare and life sciences, telecom, retail and e-commerce, government, education, energy, smart cities and logistics. With a vendor neutral strategy, every recommendation is tailored to your risk profile and business goals. In cybersecurity and compliance, empanel means a company is authorized by certifying bodies to perform audits, assessment or consulting. It signifies credibility, compliance and trust. Vista Infosec is empaneled with CREST, CERTIN, CSRO, HIPAA, ISO, IEC 27001, SOC 123, GDPR. If you are a business working with Vista Infosec, means you'll meet global and logical audit standards. You'll reduce risk of penalties. You'll gain customer trust, and your security posture will speak for itself. Now let's talk about one of the most underestimated but potentially dangerous threats in web application, that is HTML injection. Ever wonder how hackers plant malicious or misleading content into websites, sometimes even collecting your credentials using a fake form that looks just like the real thing? That is HTML injection, and today I'll show you exactly how it works. So basic of HTML injection is HTML is an hypertext markup language. It's standard markup language used to create a web pages. It is a skeleton that gives every web page structure using tags and attributes to define elements like headings, paragraphs and links. HTML injection is a web vulnerability that occurs when user input is improperly sanitized and is then rendered directly into the page's HTML output. Unlike JavaScript-based accesses, HTML injection typically affects how content is displayed, but it can still be dangerous, especially when used for phishing, UI manipulation, or even staging for more advanced attacks. HTML injection is a type of attack where malicious HTML code is inserted into a website. This can lead to a variety of issues from minor website defacement to serious data breaches. Unlike other web vulnerabilities, HTML injection targets the markup language that forms the backbone of most websites. This attack differs from other web vulnerabilities that exploit server or database weakness because it focuses on manipulating the structure and content of web page. Let's talk about the impact of HTML injection. While HTML injection might sound harmless at first glance, its impact can be very serious. Phishing. In phishing, fake login forms to steal credentials, data leakage, altering forms to collect user inputs, reputation damage, defacing content or inserting offensive content, malicious link redirection, leading users to malware-infected sites. Negligence is one of the most common root causes of HTML injection. A lack of input validation tops the list, allowing attackers to insert malicious code without verifying. Misconfigured web servers can also be exploited, offering loopholes for seasoned hackers. Lastly, insecure coding practices stemming from a lack of awareness or haste pave the way of these attacks. While these causes might seem technical, they often boil down to human error. Whether it's a developer overlooking a security measure or a server admin misconfiguring setting, the human element is ever present. Types of HTML injection. Stored HTML injection is also known as persistent injection, is a type of attack where malicious code is permanently stored on the target server. This code is then served to users every time they access a particular page. Once the malicious code is in place, it can affect a large number of users without the attackers having to do anything further. As an example, a forum post where an attacker might embed a malicious script that unsuspecting users read and then click, which initiates execution of script, leading to potential data theft or other malicious outcome. Second type of HTML injection is reflected HTML injection. Unlike stored injection, reflected attacks are not permanently housed on the server. Instead, they trick users into executing malicious code via URL. This is often achieved through phishing emails or messages that users into clicking on compromised link. For instance, an attacker might send an email posing as a trusted entity, urging the recipient to the click on link. The link contains the malicious payload, which gets executed once clicked, leading to desired malicious outcome. The third type of HTML injection is DOM-based HTML injection. The attack targets the document object model of web page, which represents the page structure. By manipulating the DOM, attackers can introduce malicious scripts that get executed client-side. Understanding the DOM is crucial for web developers and security professionals alike. It is the bridge between HTML and JavaScript, and any vulnerabilities can lead to significant security breaches. Being aware of how these attacks operate is the first step in prevention. How it works. When a web application reflects user input like in a comment section, search bar or feedback form without properly escaping HTML tags, attackers can inject their own HTML element like b style equals to color is red and some string. This is the HTML string or a tag which we can use. This simple line will show a bold red text on web page for all users who visit that page. But it doesn't stop there. Attackers can insert fake forms, modify visible content to trick users, insert links to malicious sites, and trigger unauthorized UI action. Examples of HTML injection. Here are the real-world examples and explanation of HTML injection attack, including WooCommerce incident from hijacking and page defacement. WooCommerce HTML injection attack is a popular WordPress plug-in e-commerce has experienced several HTML vulnerabilities. For instance, WooCommerce version 6.5.1 was affected by an HTML injection flaw that allowed attackers to inject malicious HTML and scripts that run in the victim's browser cortex. This can lead to cookie theft or manipulation of how site appears to users. Users were advised to update to version 6.6.0 or later to fix this vulnerability. More recently, WooCommerce version 8.0 and later has had a cross-site scripting vulnerability linked to HTML injection on registration and checkout pages. This allowed attackers to inject malicious HTML JavaScript via specially crafted links. A patch was released in version 8.9.3 and backported to version 8.8.5 to prevent this issue. Another WooCommerce vulnerability up to version 9.0.2 allowed unauthenticated attackers to inject arbitrary HTML into order form viewed by administrator, risking site security and data integrity. The fix is available in version 9.1.0 and newer. From hijacking through HTML injection. From hijacking exploits HTML injection flaws by injecting or modifying from tags on a vulnerable web page. This can redirect submitted form data, including sensitive credentials, to an attacker control server. An example found in the wild involved or a fork for Mastodon where HTML was not filtered correctly. Attackers injected form that tricked users into submitting credentials or sensitive data unknowingly by hijacking from submissions. Often attackers inject a fake login form or alter existing form actions to redirect data. This technique can also bypass content security policy, which is CSP protection, because the injected content is legitimate HTML. Preventing from hijacking requires careful validation of form actions and hard coding URLs or whitelisting allowed domains for form submissions. The third real world example is page defacement via HTML injection. HTML injection is frequently used for defacement attacks where attackers alter the visible content of web page. This ranges from showing offensive messages, advertisements, or political propaganda for completely changing the site look. Defacements undermines website credibility, disrupt services, and damage reputations. For instance, real-world defacement include attacks on government sites, commercial domains like Google Romania and PayPal Romania, and even smart advertising billboards hacked to display unauthorized content. Attackers gain access typically via vulnerabilities that enable HTML or script injection, then alter site content either directly or via compromised cloud resources. Mitigation includes implementing least privilege principles, sanitizing inputs, and monitoring for unauthorized content changes. So, WooCommerce incident highlight the risk of HTML injection in e-commerce plugins, including decision hijacking, unauthorized code execution, and admin panel exploit. From hijacking abuses HTML injection to attackers steal credentials by injecting malicious or altered form. Page defacement is a direct use of HTML injection to modify site content for various malicious purposes. Common attack methods of HTML injection related to form manipulation, content injection, and token exfiltration include the following. Form manipulation: attackers inject or modify HTML form elements on a vulnerable page to hijack submitted data. They may inject fake login forms to capture credentials and alter the action attribute of legitimate form to send data to attacker control servers. For example, inserting an extra form tag before an existing form hijacks from submission because only the first form tag takes precedence. Attackers can also use the base tag to change relative URLs so form data is redirected externally. Content injection. HTML injection can be used to alter the visible content of the web pages. This includes injecting advertisement, offensive messages, political propaganda, and misleading content. Such defacements can damage reputation and disrupt services. Stored HTML injection is typically exploited here, where injected content appears as a part of the page to all users who visit. Token exfiltration. Attackers can exfiltrate security tokens like anti-CSRF token by injecting crafted HTML tags. For example, injecting an image tag with an enclosed single quote can cause browser to interrupt subsequent input fields, including hidden CSRF token files as a part of image URL, sending them to the attacker server. Alternatively, injecting a text area inside a malicious form can capture token values if the user submits. Okay, now let's see one example of HTML injection using BWAP. BWAP is an extremely buggy web app source. Here we are taking a look at HTML injection. More specifically, we are going to be taking a look at reflected HTML injection with the post request. Now, as I mentioned, we are going to using a B box that contains B web app, and I am going to start it off using reflected injection. As here it is shows reflected post. Just going to check now. shows the reflected post using post request. So again, it's very simple. In regards to the actual injection, what is going to happen here, we are going to intercept the post request that is being sent to the server and modify the parameters or value of the parameters, and that is where we'll pass our HTML values, which will then reflect back to the user in whatever way we want, with whatever tags we want to essentially explain this concept. What I will do is, for example, here it shows welcome Alex page. Now I'll just enter the first name Alex6 and the last name as Pepe and hit go. You can see it has some predefined text, which perfectly fine. Now it shows us welcome Alex and Pepe. So we pass values as Alex and Pepe, and the request shows perfectly fine. Now I'll replace the first name with hashtag using hello, and in last name this is an HTML injection attack. So after manipulating, I just normally forwarded that, and in actual web page it shows the hello and the last name as this is an HTML injection attack. Now these are not really that complicated in regards to what their attacker is able to accomplish when performing these attacks, but irregardlessly, this is also a vulnerability. The ability to insert HTML, whether it in a post method or it a get request, of all of that we can see that the data is being processed by the server and being returned to the user in form of an HTML. How to prevent HTML injection? Developers and admin must implement several countermeasures. The key prevention method for HTML injection attacks: input validation, output encoding using framework securely, and content security policy are the fundamental defenses that, when combined, create a strong multi-layered security approach. Here is a detailed explanation based on the latest best practices and authoritative guidelines. Input validation. Purpose of this is to stop malicious HTML or script code from entering your system through user inputs. And how to implement: validate on both client and server side. Enforce strict checks on data format, length, and types before accepting input. For example, ensure emails, phone numbers, and other fields matched expected patterns. Sanitize inputs. Use dedicated libraries, example DOM Purify in JavaScript, HTML special characters in PHP, to remove or neutralize tags and attackers and attributes that could lead to injection. Prefer whitelist over blacklist. Define exactly what HTML tags or characters are allowed rather than trying to block known bad patterns which attackers can evade. Reject suspicious tags and scripts. Block or escape tags such as script, iframe, form, and event handlers like onload or on-click that can carry attack payloads. Benefits of this will prevent the initial injection vector by disallowing user data that could be interrupted as executable HTML or scripts. The second is output encoding. Purpose of this will treat user input strictly as a data rather than executable HTML or JavaScript when displayed back on the web page. How to implement: encode special characters such as single quote and symbols, double quote, and many other to their HTML entity equivalents. Context specific encoding. Use appropriate encoding techniques based on where the data will be placed. HTML encoding for text displayed in HTML content, URL encoding for data in URLs, JavaScript encoding if injecting into scripts. Utilize framework or library functions to encode output automatically and avoid manual errors. Benefit will be even if malicious input slips past validation, the encoding ensures that browsers render it as a harmless text, not executable code. Use frameworks securely. Purpose will be rely on modern web frameworks to automatically escape or isolate user inputs, reducing manual error. How to implement? Use frameworks like React, Angular, Django or others that have built-in automatic output encoding or templating engines. Avoid or carefully handle features like React's dangerously set inner HTML or Angular's bypass security APIs that disable automatic escaping. Fourth prevention is content security policy, which is CSP. Purpose of that will reduce impact of injected content by restricting what resources and script the browser is allowed to load and execute. How CSP works: delivered via HTTP response headers or meta tags. Define trusted sources for various content types, scripts, styles, images, frames, forms. Browsers enforce CSP by blocking any resource or code from unapproved originals. Key directive of CSP: default SRC fallback for all content. Script SRC, style SRC, image SRC, font SRC are defined exact trusted domains. Specifies form action. Form action specifies where form can submit data, mitigating form and hijacking. Benefit of that will mitigate execution of unauthorized inline scripts, blocks external malicious resources, and restrict form submission targets. HTML injection may seem less threatening than full-scale accesses or SQL injection, but don't be fooled. It can be a gateway to manipulation, misinformation, or worse. Protecting against it is not just about secure code, it is about respecting the trust of your users. Thank you so much for watching this video. I truly appreciate you taking the time to learn more about this important topic in cybersecurity. If you found it helpful, please like, comment and share. It really helps the channel grow and spread awareness about essential security practices. Stay safe, stay informed and stay curious, and I'll see you in the next one.